Okay, welcome. So in this example, what we're going to do is we're going to use the symmetry principle. Why? You'll see. Okay, so in this case, we've got this function and we're saying, hey, this is bounded, so we want the region that's bounded above by the graph of this curve. So what does this curve look like? Well, it's a parabola that opens down and it's 4 units up. Okay, so it's shifted 4 units up. So again, if you remember your basic functions, the basic parabola function f of x equals x squared looks like that. Okay, and it's centered on the y-axis. Okay. So now here, this one, so we've got x and y. So this one is actually going to be shifted 4 units up. Okay. So it looks something like that. Okay. And so the region we want is the region that's bounded above the x-axis by this. So it looks sort of like a football. Okay. So how do we handle this one? Well, we're going to make things very easy for ourselves by using the symmetry principle. Remember what the symmetry principle says. It says that if you draw a line symmetric, okay, the line of symmetry through an area, through a shape, through a region, okay, then the symmetry principle says the centroid must lie on that line. Well, as you can see, this is symmetric about the y-axis. Okay? So since this is symmetric about the y-axis, then the centroid must lie on the y-axis, which means x bar is automatically 0. So we already know what x bar is. X bar has to be equal to 0. So that saves us a lot of time, right? So now all we have to do is solve for y bar, right? So we still need the mass and we still need m sub x, right? So we don't have to deal with m sub y. Okay, so let's do that. Oh, by the way, we need to find the intersection points, right? Where is this equal to 0? So let's solve that first so we can find our interval of our limits of integration. So we just set this equal to 0, right? So we get negative x squared plus 4 equals 0. So we get negative x squared equals negative 4, right? And so x squared equals 4, and so x equals plus or minus 2, okay? So now we've got our two limits of integration. So it's going to go from negative 2 to 2. Okay, so now we need to find the mass, right? So again, the mass is what? It's going to be rho from A to B, but now since we're dealing with the x-axis, we're right back to the simpler version of the of this, which is going to be rho times, and then this is going to be f of x squared over 2 dx. Okay? So we're back to the simplified version. Okay, oops, wait a minute. I'm looking at the moments. I'm thinking moments here, sorry. We're talking about mass, total mass. So this is just going to be the function, f of x dx. Yep, sorry about that. Right, because this is the area times the density. Okay, so remember that. Okay, so now we've got this simplified function. And so now this is going to equal rho times the integral from -2 to 2. And this is going to be 4 minus x squared dx. Okay. Oh, by the way, if you wanted to, since this is symmetric about the y-axis, you could go from 0 to 2 and double it. So you could write this as 2 times this area. Okay, but it doesn't matter. Okay, in some cases it would be easier to do that, but you know, again, in this case, let's just stick with this. Okay, so let's integrate. So this is going to be rho times 4x minus 1/3 x cubed, right? Evaluated from -2 to 2. Okay. And in this case, actually, you know what I'm going to do? I'm just going to double it. I'm going to go from 0 to 2 and double it. Why? Because 0 is going to be a lot easier to deal with, make my calculations simpler. So let's do this. So instead of going from -2 to 2, since it's symmetric about the y-axis, I'm going to basically go from 0 to 2. That'll give me the area under half of it. And then all I have to do is just double that area, and I've got my answer. So I can just go from 0 to 2. So let's do 2 times rho. And I'm going to take 4x minus 1/3 x cubed. And I'm going to evaluate it from 0 to 2. And I'll get the same answer. Okay? So now, what do I get? I get 2 rho. This is going to be just 0 here, so I'm just going to evaluate it at 2. So this is going to be 4 times 2 minus 1/3, 2 cubed, right? And so this is going to be what? This is going to be 8 minus 8/3, right? So this is going to be 8 minus 8/3, which is going to be 6 minus 2/3, which is going to be 5 and 1/3. And so this is going to equal what? This is going to equal 16/3 times 2, which is going to be 32/3 times rho. Okay? So that's m. So we got m. So m equals 32/3 rho. Okay, so now all we have to do is find what? M sub y, or excuse me, m sub x. Oops. So m sub x is what? This is where we get rho times integral a to b, and we get f of x quantity squared over 2 dx. Okay, and so now all we're going to do is just basically plug in the values, and then we're going to integrate and evaluate. Okay, so now this is going to be rho times, again, you know what I'm going to do, instead of going from, well, let's do this, -2 to 2, and this is going to be 4 minus x squared, quantity squared over 2 dx. And so now what I'm going to do is I'm going to, again, change this from 0 to 2 and double it, okay? Okay, so let's do 2 times rho, 0 to 2, and now this is going to become 16 minus 8x squared plus x to the 4th over 2. So I'm going to pull the 2 out and make this 2 over 2, right? And so this just becomes 1. And so what I end up getting then is what? Just this, dx. And now, let's integrate. So this is going to become 16x minus 8/3 x cubed plus 1/5 x to the 5th, and we're going to evaluate it from 0 to 2. Okay, and again, because this is going to be 0 at 0, I'm just going to evaluate it at x equals 2, so this is going to end up being rho times 16 square times 2 minus 8/3 2 cubed plus 1/5 times 2 to the 5th. And what do I get? This is going to be 32. This is going to be 64/3. Right? And this is going to be, what, 32/5. Okay. So now, this is what? This is going to be 21 and 1/3. This is going to be 6 and 2/5. Right? So 32 minus, right? This is minus. So 32 minus 21 is going to give 11. And then 11 plus 6 is 17. But then we still have this negative 1/3, right? Minus 1/3 and 2/5. Right? So 1/3 plus 2/5 is going to be what? Yeah, that's right. So then this will become 1/15th, right? Because you get -5 and +6, 15th, so you get 1/15th. And so, you get 17 and 1/15th. Times rho. Okay, or this is going to be 256 over 15 rho. Okay, so that's what we get. So we get 256 over 15 rho. And now, oops. Now we're finished. Because y bar equals m sub x over m, which is going to be 32/3 rho, divided by 256 over 15 rho. And of course the rows are going to cancel. And so this equals what? 32/3 times 15 over 256. Well, 3 divides 15, so that's going to be 1 and 5. And let's see. 4 divides both of these, so that's going to give us 8 and what do we get? We get 64. Well, 8 divides both of those again, so that's going to give us 1 and 8. So the answer is going to be 5/8. And so we got our two values. Did I do something wrong? Hold on. I think I'm right. Oh, no, I didn't. You got to pay attention to what you're doing. I have these backwards. M sub x goes on top. I accidentally put this one on top. That's why. So so it's 256 over 15 over 32/3. Okay, so I had them upside down or backwards. So here. So now. Again, so this is going to end up being 256 over 15 times 3 over 32. And now things cancel, but again, it's going to be the reciprocal. So 3 goes in here 5. 32 now goes into here 8 times. Okay? And so now this is going to give us 8/5. And that's going to be our y bar, is 8/5. So our final answer, we got x bar is 0, so it's going to be 0, comma 8/5. Okay, that's it. Sorry for the little mix up here, but just pay attention And so again, this is the final answer. That's our centroid, and we're done. Okay, let's see here. Oh, one for you. Here we go. You guys try this one. Again, take your time and set it up piece by piece, and it's really straightforward. So now what we're going to do is we're going to now say we're bounded above by this function, f of x is equal to 1 minus x squared. And we're bounded below by the x-axis. And you want to find the centroid of the region. So again, graph it out, make sure you look for symmetry, and if there's symmetry, use it to your advantage to simplify your calculations. Okay? Other than that, have a great day.